decided among you who will start?
Yeah, I think it
Okay.
will be me.
Yeah, okay, the floor is yours.
Thank you. And does everybody see the presentation now?
Yeah.
Great. Okay, so I'm going to talk a bit about my ongoing study. I'm a PhD student at Chalmers, and this is my first one. So it's about hydrogen on the West Coast. And why are we interested in the West Coast? Well, we do have a couple of industries in Gothenburg, Stenungsund, and Lysekil. They are refineries in Gothenburg and Lysekil, and we have a chemical cluster in Stenungsund. And for all these industries, hydrogen is an important fuel or feedstock for the processes. And today it's mostly produced through natural gas or as a byproduct from the processes within the industries. So we wanted to see what's going to happen to the system if we produce the hydrogen through electrolysis instead, which would, of course, increase the electricity demand in the nodes. So how it is currently in the region, the Västra Götalands region, we have an annual electricity demand of 18 terawatt hours. In Gothenburg, we have approximately 4.3 terawatt hours per year, Stenungsund 1.6, and Lysekil 0.6 terawatt hours per year, approximately. And what we can expect for the future is the transportation sector that needs electricity. In Gothenburg, we have a port that could be a smaller electricity demand, but it could also be a huge electricity demand depending on how much of the fuel for the shipping sector that the port is aiming at supplying. We also have new establishments, for instance, the battery factory, which is also going to be approximately 2.2 terawatt hours per year. And then we also have the connection to the heating sector where electricity can be used for heating. So these industries are on top of this, and we can expect somewhere from 7 to 20 terawatt hours per year. And that is if we produce the hydrogen from electrolysis. So not only did we want to see what happens in the individual nodes, but also how they may collaborate. And these industries is the main focus then of my study, and see how it affects when we add this demand. So the research questions in the study is how does hydrogen demand from industries impact municipal energy systems when produced through electrolysis? How could regional collaboration in trading hydrogen through a pipeline between 3 industry-intense nodes impact the energy system configurations? And does the role of sector coupling depend on whether the demand for hydrogen is met locally or through regional collaboration in the form of a pipeline? So if we look a bit closer on these 3 areas, they differ in more than population size and annual electricity demand today. They also have different availability of import capacity from the regional grid. And I should mention that this is the approximations for the future availability of grid import from the grid. They also have a different number of ongoing offshore wind farm projects. So they are represented here in the figure. So outside Gothenburg, we had one smaller and one larger that was a bit overlapping. While in Stenungsund, we have one offshore wind farm project going on, and outside Lysekil, we have approximately 3 along the coast. So we have some availability of electricity from that. We also have solar PV park availability that's based on available land area, and rooftop solar PV availability that is dependent on the number of people living in the cities and, in extension, the amount of buildings.
Sofia, just one question that popped up here in the chat. What year
Yeah.
are these numbers for?
What year?
Yeah.
This?
Yep.
This is approximately, or well, the plans are for the grid expansion to 2035, I think. But we model a future year around 2050. So this is like what we know that we're gonna get, but then of course it's a bit of a gap between what we know we're gonna get and this year that we model. Is that the answer? And the projects are ongoing and none of them are built today when it comes to wind farms, for instance.
I hope that clarifies things for the person who asked the question here. Yeah, please
Very
carry
good
on.
question. It's an important factor, what year we model and want to investigate, of course. So, and that's the same with the hydrogen demand, for instance. That's also a maximum scenario when the industries have transitioned to not emit carbon emissions, for instance. So this is not today, but a future goal version of when the system is not allowed to emit carbon emissions or carbon dioxide. And the hydrogen demand is based on a report from RISE, where they asked different industries about what they thought was going to be their expected demand, and they gave a minimum and a maximum, and this study is based on the maximum scenario. But then again, this does not include all industries and all applications, so we still have the transportation sector outside of this demand, for instance. Lastly, we have different availability or possibility to invest in lined rock caverns. So these are the underground large storages for hydrogen, where we don't allow it in Gothenburg, but we do allow it in Stenungsund and Lysekil due to, well, the characteristics from what we've heard about the ground and so on. From these different characteristics, we have made 4 cases based on the available offshore wind farm outside Gothenburg. So Gothenburg is the node that is most congested. We have a lot of electricity demand and not a lot of either grid. Even if it's the largest of the 3 nodes, it's compared to like the demands, it's not covering for all of it. So we have 2 different wind farm sizes outside Gothenburg. The smaller one is 280 megawatts and the larger one is 1000 megawatts. And then we compare when we allow for investments in a pipeline and when we don't. And to be clear that we allow for investments in a pipeline, we don't force the model to take a decision to invest in a pipeline, but it's just a possibility. Then we go to our model. So we gave it both electricity demands, heating and hydrogen demands for each 3 of the nodes. Then we also add local wind and solar profiles as well as electricity price profiles for SE3. We give the model techno-economic data for different technologies to produce electricity, heating and hydrogen, as well as storing it. And what we get out from the model is investments and running patterns for the technologies invested in. So now I will move to the results. And here we see investments in electricity production. So this is how the results are presented. It is divided by each area or node, Gothenburg, Stenungsund and Lysekil. And then we compare with availability of the different wind farm sizes, and it's outside Gothenburg, so either a smaller one or the larger one. And then lastly, we compare with availability of a pipeline and without. So here we don't have the possibility to invest in a pipeline. And then we see in Gothenburg that we get investments in wind power, PV parks, PV on rooftops, but we also have some combined heat and power plants, as well as combined cycle gas turbines. In Stenungsund, we have only wind and solar PV. That's also because relative to the demand of electricity within Stenungsund, they have quite a good grid connection, so they can balance the intermittency of these renewable energy sources. And in Lysekil, we have a lot of wind power, some solar parks, and then a little bit of combined cycle gas turbines, as well as some PV on rooftops. And I can also mention that for all cases, the maximum PV park investment possible is taken. So it's always the maximum allowed investment in PV parks in all nodes and all cases. If we compare then when we allow for investments in a pipeline, we see that in Gothenburg we get a significant decrease in investments in electricity production, while in Stenungsund we get a larger investment in wind power. In Lysekil we also see a small increase in wind power, as well as that we don't get investments in PV on rooftops anymore, as well as combined cycle gas turbines. When we allow for the larger wind farm outside Gothenburg, I should also mention that this, of course, doesn't affect Stenungsund or Lysekil when we don't allow for the pipeline. So here, Stenungsund and Lysekil is the same as in the first case, while in Gothenburg, we see that the investment is taken in the whole available capacity of the offshore wind farm. And when we then again allow for the pipeline investments, we see that in Gothenburg that we don't change a lot. We get a bit less of combined heat power plants. And in Stenungsund, we see the same trend that we get a larger investment in offshore wind power, but in Lysekil, we get a decrease this time. And if we instead look at the electricity generation, we can see in Gothenburg and Stenungsund that over the year, it's actually mainly imported electricity that covers most of the demand. And here again, we compare with and without pipeline directly, and we see that part of the electricity supply for Gothenburg is moved, one can say, to Stenungsund, where we get a larger production than needed. So the diamonds in this plot represents the electricity demand with consideration to production of hydrogen within the node. So in Stenungsund, we produce more electricity than is needed within the node, and in Gothenburg, we in total produce less electricity than is needed in the node. And in Lysekil, we also see that we produce a bit more electricity than is needed, and that's because we again take on a bit of hydrogen production for Gothenburg, for instance. For the cases with the larger offshore wind farm, it correlates quite well to the investments in the previous graph. We get a bit less production in Gothenburg, we get more production in Stenungsund, and in Lysekil we also see that it's less electricity produced within the node. And if we move to the hydrogen part of the system, here I show both investments in electrolyzers, which is the diamond, and also the investment in different hydrogen storages. So as I mentioned earlier, lined rock caverns is not allowed in Gothenburg, but instead you can build hydrogen tanks. So in the first case, we get investments in Gothenburg of these hydrogen tanks, and we get lined rock caverns in both Stenungsund and Lysekil. When we then allow for pipeline investment, we see that the tank storage in Gothenburg decreases while the lined rock cavern storage in Stenungsund increases. And we also see that the storage in Lysekil decreases together with the increase in Stenungsund. So this already points towards that Stenungsund becomes some sort of hydrogen hub, one can say. We also see that in Gothenburg, we get a decrease in electrolyzer size, while in Stenungsund we get an increase and an increase in Lysekil as well. And this also correlates to the additional investments in electricity production. When we have a larger offshore wind power farm, then we again see investments in tank storage in Gothenburg. Stenungsund and Lysekil is the same as in the first case. And then when we allow for the pipeline, we see an even more trend towards Stenungsund being this storage that covers partly both Lysekil and Gothenburg's demand for hydrogen. And here what I find a bit interesting is that we see in Lysekil some interesting patterns that first we see an increase in electrolyzer size while the storage is decreased. And this is because in these cases with the smaller offshore wind power farm, then Gothenburg imports approximately 40% of its annual hydrogen demand. So hydrogen is transported all the way from Lysekil to Stenungsund and Gothenburg. But when we have more availability of electricity in Gothenburg, then Lysekil instead becomes an importer of hydrogen, and the pipeline helps to balance the local energy system because then Lysekil doesn't have to cover for this intermittency of variable renewable energy sources by itself, but it can rely on Stenungsund that has, for instance, better connection to the regional grid. And now we're going to focus a bit more on what's happening in Stenungsund in the case with the large offshore wind power farm and with a pipeline. So here we see the hydrogen that is transported through the pipeline between Gothenburg and Stenungsund. We see the state of charge of the lined rock cavern. We see electrolyzer load and electricity supply. And I want us to focus on this part. So here we see that there are some hours where electricity prices are high. Typically, that's when we don't want to import electricity from the regional grid. And it correlates with that we don't have a lot of wind power, and we do have some solar PV, but here it shows that it's better to export it to the regional grid than use it within the system. We see that the electrolyzer during these hours goes down to 0. So the electricity that is supplied during these hours is mainly or only for the city demand, not the industry demand. At the same time, we see that we use the lined rock cavern, so it decreases its energy content. But we continue to export hydrogen through the pipeline to Gothenburg. So this becomes an example of when the storage in Stenungsund works as a storage for Gothenburg as well. If we take a look at the system cost, we see that introducing a pipeline in these kind of models results in a lower system cost of somewhere between 4% and 7%, depending on the different scenarios and then the different availability of cheap electricity within the different nodes. And what we can conclude from this study is that meeting hydrogen from electrolyzers significantly increases the demand for electricity in the studied region. Regional collaboration through a pipeline lowers the total system cost, and the driving forces for collaboration are the different characteristics of the cities investigated. So for instance, we had Gothenburg with a high demand, quite congested, limited VRE and grid connection. We have Stenungsund, who has a comparatively large availability of VRE and also comparatively large grid connection, and Lysekil that has a lot of VRE but restricted grid connection. And because they have these different characteristics, they can then help each other in meeting these demands. And from here, this is the study I've been working on now. So we're wrapping it up. And then for future work, we're looking into how do we get there? Because as mentioned earlier, this is like a goal picture. This is 2050. This is when we don't emit carbon dioxide anymore. But we also need to get there. And we don't know exactly in what order the industry will transition to make their processes without carbon dioxide emissions. And we don't know exactly when the offshore wind power projects will occur or be built. And we also don't know really when we get this grid expansion to the regional grid. So we're going to see a bit more like what happens and how does that affect the system. And also see if it's how the pipeline correlates to it. So that's all for me. Thank you.
Thank you very much, Sofia. Thank you. So, do we have any questions? Maybe just a question for me, Sofia. I mean, we know that Svenska Kraftnät, the Swedish TSO, will have problem. There is a big gap between what they can promise to the West Swedish region compared to what the industries have sort of in their plans. So I take it that you included these limitations similar to that, or
or this is like what is currently part of the grid expansion plan. So this is based on what we know that they have promised,
exactly,
I guess, now, but then we don't know what will happen afterwards. And then again, of course, it also needs to be electricity production somewhere else in that case. So, but for the grid expansion, this is based on what we know now.
Yeah, from the TSO, what they. Yeah, exactly. Yeah. So I just point out that it's of course what you show is that it's possible but one needs to do in another way than just import, because you mentioned this import to this region. So, okay, thank you. We have a question from Bengt.
Yes, my camera doesn't work today, but anyway, I have 2 questions about the assumptions. What about the electricity market, the prices? What do you assume there? And since you're looking at investments, what do you assume about the discount rates? Thank you.
Thank you. For the electricity price, it is from another of our models within our division, and that represents again a 2050 system. It's modeled using the weather data from 2019, which I have used as well as like when I take weather data for the wind and solar power, I've also used 2019's data. And in this model, they have then projected the prices for 2050 in a system with more wind and solar than we have today. So it varies a bit more than it is now, for instance, but represents again how a future energy system could look like. And then we have an interest rate of 5%. So that's what we have in our models usually. So I guess it's maybe from an industry actor, you want it a bit higher maybe than compared to these system models, but I'm happy to get some input on this.
Well, from my perspective, is when we're doing cost-benefit analysis from the society's point of view, it's perfectly fine with 5%. So we will usually say 3.5%. But from a private investor, I guess their requirement is more than 5%, maybe 10%. I'm not sure.
I guess it will depend on the different, weighted average capital cost and all these kind of things, which is, yeah, as you say, Bengt, and also Sofia, our type of model is more like a societal cost analysis rather than some private investment cost, I think. So.
Yes, from that point of view, that the discount rate is perfectly fine, as long as it's a real discount rate, which I suppose it is. You take into account inflation and so on. But so the electricity price is based on 2019, is that right? So wasn't it very
that
low?
up, but it's modeled to represent 2050. So it's not historical data from 2019, but it's a model output from one of our larger models that model Northern European. So it's SE3 in a future system, one could say.
Yeah, it seems to me that that would be the critical parameter in this, that because it's so electricity intensive, this system. So what the price of electricity is really key, I suppose.
Yeah, in some ways. I mean, it of course it's the availability of cheap electricity that decides how we run the electrolyzers, for instance. Yeah. But as we could see from this study as well, we see that the high electricity prices correlates to when we have low availability of local wind resources, for instance. So we capture that at some hours there will be high prices and low availability of renewables, and then we see what is the most cost optimal. And the most cost optimal in this case is not then to maybe build more combined heat power plants or so. It's to avoid these hours and have some storage that can then cover for these hours.
Good, thank you.
Thank you.
Thanks, good. Do we have another question? I guess maybe a comment there, Sofia, relates to Bengt's question, is that, of course, this system is sort of an optimized system. So, of course, another thing would be, how can this be built out in a timely manner so the demand, should the demand come first or the generation and all that, which is a quite different thing. So, but in a future system with a lot of renewable power, electricity, the prices will not necessarily be high, but will be, of course, dependent a lot on these flexibility measures that you study, I think so. Okay, if there are no other question at the moment, maybe you can also think we can hopefully have some maybe question time in the end. So then I think we can go for Björn. Looking forward to your presentation. So
thank you. Very nice to meet you all. Before I start, I would assume that most people in the meeting are focused on electricity. Is that true, or is that also gas-focused people in the meeting?
I don't know. We are not so into fertilizers, that I can say. But it's very important.
It is. Without fertilizers, we don't have much food.
No, exactly.
Modern, in the modern agriculture.
But I think all of us are aware of that. Of course, in the future we have more and more of this sort of sector coupling. Everything, so to say, depend on each other, which is a little bit different from historically. So I think that's a good point, that we should care about the gas and so on. So we do. Definitely. To some extent, but yeah.
Okay. So thank you very much, Sofia. I really liked the second time I see the presentation, and it just confirms our position that to build the new energy system that the industry and the society needs, we need to have hydrogen infrastructure connecting production and offtake, and to make sure that we can balance the entire system. And I'm representing the hydrogen business and infrastructure within Nordion Energi. And Nordion Energi is focused only on infrastructure, on electricity and gas. So we are the gas TSO and DSO for methane, so natural gas and biogas in this part of Sweden. And we also an electricity DSO in Falbygden Energi. So we don't have a conflict about electricity or gas. We try to maximize the benefit of each system. And we take great pride in having a very high level of security of supply. So for the gas TSO, it's very close to 100%. And this is very important, the security of supply, making sure that the society and the industry have access to a cost-efficient energy, whether it's in the form of electricity or hydrogen or methane. We are owned by an European pension fund focused only on infrastructure. So everything we do is transparent, it's long-term, and it should be reliable. So in the business model, to come back to being a private company, if we have the long-term view, we can also allow lower sort of profit margin or risk margin, because then we have a solid business for a long time. So low margin, but a safe long-term view. So that's the basic of infrastructure investments. The current system is, it was 2022 up to 37% fed by biogas. It went down because the tax rules were changed last year. But we're aiming on reaching 100% green gas, so it's biogas only by 2030. We are not producing ourselves, so we need to work with partners and to make sure we enable to get all the molecules into the system. That is also then increasing the security of supply for the entire system. We're also working with liquid biogas with a project in the harbor of Gothenburg. We're working with CCUS project both in Gothenburg and in Malmö. So we really try to get all the infrastructure parts needed to go for sector coupling, to make sure we do something better than we've done before, integrating the energy system and really making sure that we build a good system. But this is focused on hydrogen. Europe believes that hydrogen is a very important part in the new system for Europe, for each country. So we were approved with our two big projects, 8th of April, so last week, as a project of common interest, both for the Nordic hydrogen route and for the Baltic Sea hydrogen collector. And I will come back later to the power to earth, the project together with Fertiberia and Lantmännen. This is the first section of the Nordic hydrogen route project. The need of hydrogen. We see a lot of power points. There's a lot of communication around hydrogen, but we wanted to find out on a confidential basis, so I cannot share all the details. What is the current concrete plans for locations with coordinates, timelines, capacities, that both in production and offtake? What is it that we have currently in Sweden? So we have not just looked on the official numbers. We wanted to find out what's the truth. And so far, the majority has been sort of focused on the northern part of Sweden, SE1, SE2. But there's already now information about SE3, SE4 as well. So for now, this is the result by end of October last year. 29 companies with 50 concrete projects. And the numbers showing here adds up to 55 terawatt hours by 2045 in consumption and 80 terawatt hours of production. But it starts already around 2028, that there's plans, if there's a connection between a producer and an offtake, so you have a connection, you have a value chain, then that could be started already in 2028. And what does the infrastructure give? Yeah, we can connect the different system. We can complement the grid from Svenska kraftnät. So where there's a limitation to add overhead power lines, we can build the underground pipeline instead. We can also go directly to the source. We can go for off-grid solutions as well. So this is just showing it's underground, so it's not impacting nature society more than when it's being installed. So the reindeers and the mooses, elks can walk over it, you can still farm the land, etc. And apart from being very efficient in space, so with clearance of 20 meters, you can have a 1.2 meter pipeline that transport the same amount of energy as 14 overhead high voltage power lines to transport 42 gigawatts. So it's a huge capacity in a single pipe. So if you transfer that into a cost per one unit per, I think it's 1,000 meter. So the levelized cost of transmission of quite a big number, 6 gigawatts. But you see that as soon as you come up to like 100 kilometer, you have a very clear cost benefit compared to the normal system of using an overhead 400 kV lines. But what is very important, we don't say stop with electricity. This is super important. This is the backbone of the Swedish energy system. But what we need is to complement that into a new system where we can also easier handle the volatility in supply on the renewable power production, and still keeping the quite stable offtake need from the industry. So the projects, the Nordic hydrogen route is really to connect Finland and Sweden up north, where we have huge potentials, we have huge projects, but in order to get the balance between supply and demand, we need to connect it to a bigger system. We got the PCI status, we are just preparing the CEF application for getting additional funding from EU. The power to earth is the first section. I will show that on the map next. We are then also using the input from the open season to really see where is the demand, how can we best have an infrastructure to meet that. So we have the coordinates. We also have spent a lot of times just in this coastal area. It's been more than, I think it's 60 or 70 meetings now with hundreds of people talking to the municipalities. What are the needs? What is the local value, the regional value that we can create? Also been working quite a lot how to connect and do co-laying of electricity power line and hydrogen pipelines, because we have that knowledge already from today from the west coast of Sweden for the methane system. So we use the same kind of experience there. So this is the part going from Letsi in Jokkmokk municipality down to Luleå. So this is the first section. There's a very good connection for power up in Letsi next to a hydro power plant. And we have an excellent opportunity with Fertiliser to build both the green ammonia and green fertilizers in Luleå and the Hatcherfältet. So we go and sort of pick up the energy where it's available. We produce a hydrogen and then transfer it in a 150-kilometer underground pipeline, which is then much easier to get into this narrow space between military areas and nature areas, different difficult geological conditions, etc. Then we get it to a port of Luleå with an excellent infrastructure as well. We have already started the early consultations with Sami villages, with all the municipalities, with Länsstyrelsen. So the permitting for all the 4 parts, the grid connection, the hydrogen production, the hydrogen underground pipeline, and for the production unit in Luleå. All the processes are now initiated. So we are moving ahead to reach an FID, to take financial decision. This is targeted for end of 2025, to be in operation end of 2028. And this is a challenge, yes. But why do we do this? Sweden don't have any domestic production of ammonia. This has been imported from Belarus, from Russia, etc. We don't have any domestic production of fertilizers. This has also been supplied quite a lot from Eastern Europe, so we need to stop that. We need to be self-sufficient or supplying in the country. So in times of difficulties, then we have more control of our own food supply chain in Sweden. This part, because it's the first section of an open system, it needs already from the start to be addressed as an open system. So the capacity should not only be to enable the Power to Earth project, it needs also to accommodate for the future energy system, connecting up in the Malmbergen down to the biogenic CO2 sources along the coast, to really to create a big new energy system. And this is really about accelerating and also creating this new path of creating the energy infrastructure up north. Because building huge power lines, it is a challenge up north. There's a lot of area, but very little space. So we're developing the project with the 3 partners together, and we're driving this now fast forward together, and working quite a lot with keeping authorities on their toes. We have already agreed on the legal framework, even if it's not clear, even if it's not perfect. It's enough that we start now. We don't have to wait. We go for it. I also want to touch on the Baltic Sea. I was in Malmö yesterday talking with offshore wind and with concerning hydrogen. So this is an excellent opportunity both on the Baltic Sea and on the west coast to connect offshore renewable power generation and connect that to a market. And one cost-efficient way to do that is to produce hydrogen and have an infrastructure of hydrogen to connect it to a market. So in all these types of investment, you need to have a sort of a secured offtake, but also if you go for an investment to change to a new energy supply, you need to have a secure supply situation. So you really need to connect the two. And of course, then have a cost efficient, the right price, having the permitting in place, but then you can have a business and you go for an investment decision. This is also PCI status. It's a CEF application. We're working also with the TSO in Germany. So we have a great connection on how to build the energy system together. But it should not be to drain the energy that we are producing in Sweden. It should just be to secure the energy system, securing the supply, to make sure that we can go for the big green transition that we need to do in Sweden, in Europe, and as such. West Coast. This is already where we use hydrogen. So for me, I'm a little bit puzzled still that most people talk only about the northern part of Sweden. There's also a great knowledge and experience, and Chalmers is showing that. I'm very sure that the fire brigade, the municipalities, the Länsstyrelsen, they are already so aware of sort of gases, explosive materials. So this is a sort of normal business. There's already a knowledge about gas infrastructure. which is currently representing 20% of the energy supply in the region on the west coast and Skåne. There's also, like pointed out, is a limitation in capacity in to supply electricity, the power capacity limitation. So this is really where we want to see concrete projects and to start with partners to get anything from an initiative to a project. Let's see. And get full. So what we want to see is really that we aim on the energy system that we need to reach the planning targets that the government has set in the proposal for the proposition to reach the 300 plus terawatt hours by 2045. So we need to connect, we need to make sure that we utilize the resources in the right location. So we're already working very closely with Svenska Kraftnät, doing system analysis and starting on the path of co-planning to make sure that we build where we have the right conditions for each system to combine that in a new system. And then, of course, the sector couplings, where we have biogenic CO2, where we have waste heat that can be used to replace district heating. Can we use the biomass for biogas production instead? So there's a lot of components that we need to have in place to make the right decisions. And the Energy Agency report from the 26th of March, it was stating that we need to combine the knowledge and experience from methane with hydrogen. It's really a gas infrastructure, so keep it together. And we do have the knowledge and competence and the experience from within Nordion Energy to provide that to secure that this is going in a good path forward. The rules and regulations are sufficient. They're not perfect, but we want to sort of improve as we move forward and make sure that we do this co-planning in a consistent and very constructive way. So the conclusion is basically go now, and this is what we do. And just the last point, Europe. We're a part of Europe, whether we like it or not. And we do have an integrated energy system already today. And we need to make sure that the future system for hydrogen infrastructure is also then set in the right framework. So we are working now during this period up until June, together with the other gas TSOs in Europe, to put in place the NOH, the European Network of Network Operators for Hydrogen. So we're the only representative from Sweden. And this is really to make sure that how decisions are made, what are the framework that will be put in place, that this is something that is good also for Sweden. So this is what we do, and that should be ready before July this summer, and then be handed over to ACER. So do not consider to act. Act. This is really important. Thank you.
Thank you very much. Thank you. Thank you very much, Björn. So do we have some questions on this interesting talk? There seems to be a lot in the pipeline, so to say, to be witty.
Good expression.
Yeah. A question there maybe from me is that, of course, there is a lot of things. It seems to be a lot of already being started with sort of Norway, Germany, Denmark context. So maybe just from looking at the outside, it's a bit surprised that in your infrastructure, what you show, a possible connection, say, from the west coast directly to Denmark, that was only appeared in one of your last slides. But wouldn't that be something that could be of interest? Because it's, after all, it's compared to the other distances that you showed, it's quite short distance. I mean, of course we have it from the south, but yeah, there's a lot. Isn't it a risk that we get miss the train, so to say?
Very good point. And that is the frustration that we have told the politicians, the authorities, that if we wait too long, then we will just be sitting in the back seat of the car. So Denmark, Norway, Finland is also starting to get a position on how to connect the energy system to make sure that you create the benefits within the country, utilize the opportunities for new industry, for new workplaces, but then also connect to enable the connection for security of supply, helping to decarbonize other parts of Europe as well. So this is a fact, but we have a cooperation agreement with all the gas TSOs around the Baltic Sea. We have very frequent discussion with the German DNA, BMWK, with Energi concerning connection Sweden, Denmark. So this has been discussed since at least 2 years. And so what we need is a concrete project on the West Coast. So what is the supply? What is the offtake? How does that match with the needs and the opportunities in Denmark? There's gas storage opportunities in Denmark that can be utilized. But right now they have 100% focus on building the pipeline system that they have agreed connecting Denmark and Germany. But if we sit waiting, then there's a lot of new investments in renewable power production, hydrogen production that will never happen in Sweden if we don't take an active role as Sweden. We are pushing forward as much as we can from our side to make sure that we are in dialogue, that we are creating concrete projects, because we cannot wait. But we need to make sure that we are doing the right for Sweden.
Yeah, good. Good that you're active. So any other points? Not. Well, another what I was thinking is, of course, you're right that, I mean, the cost of transporting hydrogen seems to be attractive compared to electricity, and of course also with this we know all these permitting challenges for overhead lines in particular for electricity. But of course you need, of course, to produce the hydrogen. But so I mean, of course, you at somewhere you need electricity transmission in any case. But I guess what your point is that you just sort of change, you get more degrees of freedom where to put the electricity infrastructure if you can also play around with hydrogen, I guess. So yes, it's but the challenge is, of course, the production. Well, I mean, there is a challenge in producing hydrogen, of course, and so.
Yeah, and the fact is that you don't need to start with the electrical grid. You can start with an energy production. So if there's a wind park that can produce energy that's turned into hydrogen, and then it can feed into the system through a hydrogen pipeline. But of course, hydrogen is not the solution to everything. If you want to convert it back on a continuous basis to electricity, the efficiency is too low. If you use it to balance on the capacity issue, then I think it's a very good solution if it's already available.
Yeah. So, I mean, there will be hours that are worth a lot, and then it may be, we have another PhD student who looked at that with gas turbines with powered partly or entirely by hydrogen, and those could be coming in for those rather few hours that are critical. Although then probably one needs some sort of procured capacity market or something for that. But,
yes. And of course, presenting these huge projects, the Baltic Sea Hydrogen Collector combined with Nordic Hydrogen Route, that's more than 200 million SEK in investment. So of course, we are doing the NHR project together with the Finnish state on company gas grid. In the Baltic Sea, it's together with OX2, with gas grid, and with Copenhagen Infrastructure Partner. That there's need for doing a lot of project financing to get the full project in place. But that's why we start with the power to earth. That this is a concrete, it's big enough for sure, but it's a concrete project with a concrete production, concrete offtake, and we have a distance. We have already started the permitting. So this is really to show that it works.
Yeah.
And then we just have to have that sort of long-term view when we should have the entire system in operation, but it's all based on the need. We don't make plans because we think it's nice and it would be nice to have. And it needs always to be the need from the society and industry, how we can meet the green transition to take out all the fossil energy that we have today and replace it with new. So we cannot just take it away. We need to replace it with something. And this is
Yeah,
why
yeah,
we
of
build
course,
the
yeah.
infrastructure to make that happen.
So no other questions? I think you can also ask for Sofia's presentation. But I see no hands up. But
Yeah.
another maybe about fertilizer. I mean, I think it was a very good point you made that of course self-sufficiency. We don't have currently any. We have to rely on import. So, but then of course maybe it's outside your scope. But why is it a Spanish company? One could think of, I don't know, Swedish companies or that could build this, or what's in it for them and what's in it for us. I mean, of course, it'd be good to have a factory in Sweden, obviously, but yeah. Do you have any comment on that, or?
And someone needs to do it, and of course, Fertiberia is a company that don't have a lot of sort of stranded asset. They are already they have already the first green fertilizer production in Puertollano in Spain, and they want to work in other geographies as well. So they have the knowledge, they have the access to the markets, and also through Lantmännen. And then of course we are very well positioned to have the offtake directly in Sweden, and then produce enough also for export, of course.
Yeah.
So you need companies that have the guts and the will and the plans to do it.
We cannot force someone to open up a fertilizer factory, of course, but yeah.
And one comment on Sofia's presentation.
Yeah.
Apart from the hybrid line rock cavern, there's already a line rock cavern that we are owning and operating. It was built about 20 years ago, Skallen, which is north of Halmstad. It's used for methane, but it's already there. It's working on a daily basis, so we know how it works, and we know also the next one, how that should be improved to build it even better. And it was the blueprint for hybrids.
Yeah. There was a question in the chat. What is the name of the Spanish company? And it's
Grupo Fertiberia.
Fertiberia, yeah. So yeah, but I think also the Vattenfall also their pilot line rock cavern turned out to work beyond expectations as far as I understand. So it works very well. So that's. And I guess for your industrial project that you had on this map, that was included also all these kind of projects that have been, maybe officially and unofficially also presented, including the iron and steel sector, I guess, the map you showed. Yeah.
That's correct.
Yeah. So yeah, and I think but for both your presentations, obviously, I think that the challenge is how can we get this to materialize in terms of that we get enough production in a timely manner, expanding that at the same time as the demand expands, and there's of course a risk that the investments. Yeah, I guess we need a lot of these kind of long-term agreements between different companies in order to get this in place, as I think was indicated from your presentation, Björn, to get this. Otherwise, we risk periods with very low electricity prices, which will be a sort of a problem for those who invest in generation. And of course, if the generation lags, then those who will use the electricity or hydrogen will have problems with high electricity prices. I guess that's maybe one of the main challenges to get this timely expansion.
Yes. So we need to clarify roles and responsibilities, authorities and other actors. And then, of course, also having a direction that's clear from the government. This is what we want to do.
Yeah.
This is direction.
There was a comment in the chat that Spanish Iberdrola is investing in Swedish offshore wind also. I spot a pattern. Yeah, maybe their Spain is conquering Sweden. I don't know.
They are very much into renewable power, and there's been a lot of investment. So they have already learned a lot. Iberdrola is also working with Fertiberia, and they're working with H2 Green Steel. So so that's good.
Okay, time is 10 o'clock, and there seems to be no more questions. I think this was a very, very interesting, and I think there is a lot. One can almost get a little bit depressed by the political debate, that it's so polarized, whereas there is so much interesting things that can be done. And of course, Sweden, we have a very good conditions compared to many other countries. So I think both your presentations really show all the possibilities that we have. So from a Swedish perspective and so on.
So let's realize Sofia's plans.
Yeah, exactly. Just to go out there and do it. Yeah, exactly. Yeah. Okay. Are there anything, Daniel? No, I think there is. We are also planning if there is something more we should. Yeah, in the misclarification project, we're planning also for a webinar. We haven't decided the date yet, but it will be about flexibility for heat pumps, because we also electrify the heating sector. So that's also something on smart use of heat and electricity. So we'll focus that in our next presentation, probably some date in May next month. So okay, but I thank Björn and Sofia and all others who are listening, and thanks a lot, and well, see you next time. Bye.
Thanks a lot.
Bye.
Have a nice day.
You.
Bye.
Bye-bye.